what you will do, not trial and error, you will do it, you would draw a sketch of this because we have the points. Then you would be able to find out which two vectors you should be using. Do not do that trial and error thing, please. You're wasting your time. Okay? So if I have my Cartesian plane, I'm just drawing it on this thing, so you can see yeah, anyways. Actually, no, let me go to the other one. So it's 1, 1, 3 minus 1 and 4, 4.
Because I told you we should draw it.
Well, yeah, you have to
told you
draw
you
it, but
should
then
draw
you
it.
still have to do the dot product. You can't just, drop a right angle symbol on that diagram and say, boom, okay, I showed you, move on with life. No, you can't do that, okay? So it's a 1, 1. So remember the position, okay, let me write that out. Position vectors. So that's the vectors that start with O, right? Symbolizing that they start from the origin. If I'm given this column vector, so OR is 1, 1. Now we said position vectors actually tells us the coordinates of the point. So if I have the position vector OR is 1, 1, that means that the coordinates of the point R is 1, 1. So for S, it would be 3 minus 1 because OS was given as 3 minus 1. Then they told me OT is 4, 4. Therefore, the point T as the coordinates 4, 4. So if I have the position vector, I can actually find the coordinates of a point, right? We actually went through that before. Hold on, give me a sec.
We did? My goodness, I must be blind and deaf then.
Maybe, I don't know. Anyways. But yes, we did. Like long time ago. Okay, erasing this. Right, so I said a sketch would help you because you need to find out which two vectors you should be using, right? So you have a Cartesian plane, yeah. Let me use yellow. So I want the point R. So on the x-axis, this is x, right? Horizontal is x, vertical is y. So let me say this is 1 and this is 1. Then this right here is my point R. S, let me say 3 is around here, minus 1 is down here. So then this is S. And let me say 4 is around here. And 4 is up here. So this is P. Let me use a different color to label them. R, S, T. I connect these crosses. Let me redraw that line. Anyways, that diagram is kind of wonky, but like, I hope that you see the right angle is really me. They said they want me to show that TRS is equal to 90 degrees. TRS, so they're referring to this angle here, this angle in the green, that's the 90 degrees. So what does that mean? If I want to show them that the angle between, well, this angle is 90 degrees, that means I have to use this vector, TR, and then this vector, RS. That's the dot product that I need to find. The dot product of TR and RS. Do you understand that? Yes, no, maybe. Repeat one more time.
Not
Hello?
even maybe, boy. I'm just in the trenches.
What are you confused about?
Miss, what kind of triangle is that?
A right angle triangle, it looks weird because, yeah.
Miss, no right angle triangle shape, so.
Oh, the
Miss
person
Trial
was-
and Error is looking very lovelicious right now.
it should look like, even this doesn't even look good anyways, but it should look something like this. And they actually told me TRS is 90. So this is my 90-degree angle right here. TRS. They told me to show that TRS is 90 degrees. So this is the 90-degree angle right here. But we said in order to show that the angle is 90 degrees, we need to find the dot product. But we didn't know what two vectors we should be using to find the dot product. Now that I have this diagram though, I know that the two vectors I would be using would be TR and RS, because the 90 degrees is the angle between these two vectors. Do you understand that?
Yes, miss, that actually makes sense.
Yes, miss.
Okay. Bruh.
So Miss
why
Stacy, what we
this
do
in a
is,
triangle?
Miss Stacy, what we do is those two lines that make the right angle, we just do one thing with them, right?
Find the dot product with that? Yes.
Yes.
But there's a problem. I don't have those two vectors. I need to find it. They gave me OR, OS, and OT. They did not give me TR and TS. I mean, TR and RS. So of course I need to find those vectors first. Do you understand that? Okay, just in case you kind of lost, we want to find the dot product of these two vectors, TR and RS. We need to show that the dot product is equal to 0. But in order to find the dot product of these two vectors, I need the two vectors. I don't know what those two vectors are. Why? Because they gave me 3 vectors, yeah, but they gave me OR, OS, and OT. They did not give me the vectors TR and TS. So I need to find those. That's the only way I can find the dot product between them. Do you understand that? No.
Yes, miss.
Yes, miss.
Okay, so can somebody tell me how would we find the vector TR? They gave me position vectors.
Find its
OR,
dot
OS.
product? Question mark.
Wait, repeat that.
Yes, find its dot product? Question mark.
Dot product to find TR.
Or we could just use T and an R.
Oh wait, miss, we can just add the add the things, the X and the Y values. Question mark.
Well, it has to do something with vector addition. So TR would be
Magnitude.
TO plus OR. Do you remember that? They did not give me these pointers. They gave me OR, OS, OT. They gave me position vectors, and because I had position vectors, that's how I knew the points. But they really gave us OR is 1, 1. OS is 3 minus 1. And OT is 4, 4. So if I want to find TR, it would be TO plus OR. Do you remember that? well, the people who were with me when we did vector addition.
Oh yes, miss. I was confused because that R looks like an A.
Anyways, so TO is minus OT. I hope you remember that. So that would be minus 4 plus OR, which is 1, 1. I add these two vectors and I will get, and just fit this up here, minus 4 plus 1, that's minus 3, and then the same thing below, minus 3. So my vector TR is minus 3, minus 3. Do you understand that? Like, we can't move on to other subtopics and then you forget how to do subtopics from before, right? That's not how it works. You need to remember what we did. Because even though we're doing dot
TO
products,
plus OR.
Yeah.
Miss,
Can you show me where TO is on that Cartesian plane?
so this right here, this is not TO, right? We were just using the points T, S, and R. We were not using their position vectors. We were using the points. Okay. So don't look at this diagram for OT. OT. That diagram was us using the points RST. Now we're using their position vectors. So if I want,
Oh, TO is the opposite of OT. Oh my gosh. I now
oh my
realize that.
gosh, that's funny. Yes,
Miss, the
yes,
whole
yes.
time I'm looking like, where the hell is OT? Where is OT? Where is TO, I mean? And I'm just like, what? And then I looked at the
Yes.
values, I'm like, negative.
I realize it now. So basically, miss, when you flip it around, it's just negative.
Yes, of course. I thought you understood that. Okay, let me start making assumptions now. So this is the original line I had, but TO is the opposite of OT. So then I would say minus OT plus OR. And minus OT, which is minus 4, 4, would give me minus 4, minus 4. Let me just write that out as well. Minus OT plus OR. We know when, from scalar multiplication, when multiplying a scalar value by a vector, you need to multiply the number by both the x component and the y component. So this would really be minus 4. So it's minus 1 times 4. So it's minus 4. And then minus 1 times 4, also minus 4. Plus 1, 1. Is that clearer now?
Yes, miss. That actually makes
Yeah,
sense.
miss, it's clear.
Okay, nice. And then we got minus 3, minus 3. Do you understand that?
Yes,
Yeah,
miss.
miss, addition, of course.
Okay. Well, you were the people telling me that 14 plus 15 is 19. So
All right, miss. All right, miss. We see where you're coming from. So, miss, our next class is on addition.
yes, I think we might have to do that.
All right, miss. Lovely stuff. Also, if possible, I've been having my struggles with 3 times table. So after class, we can hit some of that.
RS
Mood.
would be RO plus OS. But RO is the opposite of OR, as you put it. So this would be minus OR plus OS. So this would be minus, minus 1, 1, because that's OR. OR is 1, 1. And then OS is 3 minus 1. I simplified this a bit. So -1 times 1 is -1. -1 times 1 is -1. Plus 3 minus 1. That would give me, what would this give me?
So basically 2 on -2.
2 on 1?
-2, right? Yeah, -2.
Yeah. Okay, so that's what we're trying to find, the dot product between -3 and 2 2. So we know to find the dot product is the product of the x components plus the product of the y components. So that would be -3 times 2 plus -3 times -2. -3 times 2, that's -6, plus -3 times -3 is +6, -6 plus +6 is 0. And then you would state, since the dot product is 0, then the angle is 90 degrees. So you make a final statement. Is that fine?
Yes, Miss, that's clear.
Okay, cool.